Hey folks, this is Mrs. O'Brien, and I just want to work with you a little bit on the technology of manually fitting data which you think is sinusoidal. Now, the example I'm going to do is on page 925 of the book my students are piloting. The data is presented here on this chart. The X, or the independent variable, is the month, and the month is being used to predict Y, which is the average temperature in Chicago during that month. Our goal is to fit the curve with a function of the form a sine or cosine omega x minus h plus k. With that said, stop the video right now and input the data, and when you're ready, just turn it back on. So here we go. My data's in. I'm going to add a new page, which is a data and statistics page. I'm going to graph month versus average temperature. Now, the first thing I'd like to do is plot the midline. With that said, if I go back here, I know the midline, which is my K, is the highest score plus the lowest score divided by 2, which in this case is 48.9. So if we go back into this document, I can go Menu, Analyze, Plot a function, and I'm saying let's plot 48.9. Now that helps me see things. I know it would be easier to fit this with a cosine because it's starting, it seems to be underneath the midline, but I'm going to just do sine for fun so that we can look at phase shifts too. So right now, let's go back here and go into my notes. And I know right now that this is 48.9. And now let's go for the amplitude. The amplitude is half the difference between the highest value and the lowest value. So my amplitude is going to be 25.1. Now, in terms of my omega, I can look at this graph and I can pretty much see that it takes 12 months to complete a cycle. Or I can just use common sense that the temperature repeats every 12 months, or not exactly repeats, but it'll have the same trends. So using the formula for omega, I know 2 pi divided by omega equals the period, which is 12 months. Solving for omega, I get 2 pi over 12, which is pi over 6. So the only thing missing right now is my phase shift. So I'm going to go into my handy dandy calculator and I'm going to go Menu, Analyze, and I'm going to plot a function. Now I'm going to put in 25.1 times the trig function sine, and the omega was pi over 6, so I'm going to go Control divide pi over 6. Gonna arrow over, and I'm going to put in my phase shift here. I don't know what it is yet, but I'm going to put it in as x minus 0. And then I'm going to skip outside of here, and I'm going to go plus 48.9. Now looking at this, you can see that the curve needs to be shifted to the right. Right meaning that it's going to be a minus instead of a plus. It would really be nice to know the two values of the maximums, because if I know the maximum on this top point and this top point, I can know to shift it that amount. Well, if I go to Menu, Analyze, there should be a trace here, graph trace, and I can just kind of scoot this over to what looks like the maximum. And the maximum looks like it's happening somewhere about 3. Now, if I down arrow, it puts me on the scatter plot, and I can see by tracing over with the arrow that it looks like this maximum, let's see, month 4, 6, 7, that this maximum, and I just want to drag this over there, is at about 7. So I'm going from 3 to 7. So I'm going to go here. Oh no, my function disappeared. Let's hit escape. And I want to see if I can get that function back, because this is something that could happen to you. Let's see, go menu, analyze, plot function. Okay, that's not making me happy. I wish that 4 were over there. Ah, there it is. I clicked on it and there it is. Okay, I'm going to click in this formula box and I'm going to arrow over, not quite as far as that just went. And I'm going to go and I'm going to change this, going to go delete to a 4 and hit enter. Now I could play with this a little bit. I can click on this again and arrow over, and maybe I want to go right a little bit more. I could say like 4.1 and it's smidgen better. So right there, that's the equation that I fit manually. I could also go menu, analyze, regression, sinusoidal, and this right here will be the sinusoidal. Now I got 2 different curves up here. This is F3, and it would be easier to see the other one if it were different. So I hope you carried it down before, because if F4 is on there, there it is. I kind of found the difference. That's the regression. So whichever curve you click on, it's going to show you its equation. Have fun with the homework tonight, and don't let the technology scare you. Bye.